This is a plan view of a vertical cylindrical heater. You can see over here, we have the outside casing, structural supports over here, and then we have the refractory lining on the outside and tubes in a circle, and then we have burners in a circle, and then there is an access door. We have peep doors. So that's typically the how the heater floor for a vertical cylindrical heater will look like. This is a cabin heater, horizontal tube cabin heater, and here we are showing you the upper radiant section and arch section. Arch is basically the roof of the radiant section, and then we have the convection section, and you can see the header boxes of the convection and the radiant over here. That's basically how the upper section and radiant section are. And then we are talking of the convection section. So convection section in fat heaters generally has the same shape. We have tubes in a horizontal manner arranged in a triangular pitch at 2D spacing most of the time. The first 3 rows are bare tubes, and then we have finned or studded tubes for better heat transfer. So that's typically how the convection section is designed. So this is a plan view of a convection section on a vertical cylindrical heater. This is the fluid inlets you can see over here, and then the pipe which transfers the fluid from the convection section to the radiant section is known as crossovers. And these days we always have external crossovers for ease of construction. We also have a tube pulling door for removing tubes in the radiant section. This is the cross-section view of the convection section here. So convection section can consist of bare tubes in the bottom, you can see over here. And then we have fin tubes and studded tubes over here. And we have refractory baffles on both sides to prevent flue gas bypassing. That's typically how the convection sections are constructed. We are showing fin tubes and we are showing studded tubes. Fin tubes are used in gas firing. Studded tubes are used in oil firing. So that's basically how the difference. Most of the heaters these days, since we are firing gas only, have fin tubes. And then we have intermediate tube sheets because horizontal tubes require supports every 35 diameters. So we have these high alloy tube sheets which support the convection section tubes every 35 diameters. That's typically how the construction is. And then once the heat is recovered, we have the flue gas offtakes, you can see over here, and then you can see the stack, which is used for disposing the flue gas. We also have a damper here. So that's typically how this is the convection section, this is the radiant section, So that's the third component, basically the stack and the offtakes. So as we said, stacks have an important function of creating draft. And you can see over here in this picture, ladders, platforms, helical strakes for keeping the stack structurally stable. That's typically what we have. And then we sometimes have stack tip with a reduced diameter for higher flue gas velocity. So that's basically how the stacks are functioning. So let's talk about different types of heaters. The heaters can be classified in a number of ways. We can classify it as per firebox, as per the coil layout, how the firing is, and how the draft is provided. So they basically dependent on different types. So we have two configurations, vertical cylindrical and box heaters. These are the two configurations what we normally have. So I want to find out what is the orientation of your radiant coil. Radiant coil. So is it vertical? Is it horizontal? Is it helical? Or none of these? So most of the heaters or majority of you have answered vertical coils, 60%, and 30% have answered horizontal. Helical coils are used in small heaters. Horizontal coils were historically provided in all the old heaters. All the old heaters used to have horizontal coils. And slowly the industry has been moving towards vertical coils because vertical coils are easier to support. You can support it from the top, and then basically uh, you don't need to have any intermediate support. So vertical tubes remain straight also. So because of that, vertical tubes are preferred nowadays. As you can see over here, 61% of people are saying. So this is the horizontal tube heater, cabin heater, and this is a vertical tube heater. You can see over here, vertical tube heater. Vertical cylindrical heaters are generally having vertical tubes. So I want to ask you, how are your radiant tubes supported? Are they supported from horizontal supports if they have horizontal? If you have vertical, are they supported from top or they are supported from bottom? Or maybe you don't have any supports. Doesn't look like that to be the case, but that could be another option here. So as you can see, top in vertical heaters, top support is most common. Bottom support is used in smaller heaters, and horizontal supports are used in horizontal tube heaters. So of course, nobody has no supports. Everybody has some type of supports. And along with supports, we have guides. So typically, if it's a top supported, we will have bottom guided. If we have bottom supported, it will be top guided. And even sometimes intermediate guides are also there. On horizontal supports, we don't need any guides, but we do need some locking bars for preventing the jumping of tubes. That is provided in reboiler services or vaporizing services. That's typically how. So this is a picture of a radiant tube guide. As I said, it's important to have these guides free because these tubes are supposed to expand downwards when they get heated up. So these things needs to be free. Otherwise, what will happen is if they are stuck, you may get bowing of tubes. So sometimes bowing of tubes is because both ends are restricted, so the tube has nowhere to go but to bow. Two common configurations. Vertical cylindrical heater is a very common configuration, and horizontal tube cabin heater is another common configuration. So most of the heaters today are built in these two configurations, although if you look at 50 years old or 100-year-old heater, 70 years old heater, you will see all sorts of shapes and sizes which were built by the refiners at that time. So here is a question for you. Where are your burners located? Are they on the roof, floor, sidewall, end walls? So typically burners are on the roof in steam methane reformers. Well, as you can see, most of the heaters have floor firing, and that is the most common these days. In the old days, old heaters, we would have burners on the end firing horizontally, or some heaters like steam methane reformers or even cracking heaters, ethylene cracking heaters have burners on the side walls. Roof is only steam methane reformers firing down. So, well, thank you for your feedback. One of the things which is very important is uniform heat distribution, and the burner's location and the number is one of the main causes how these get how important or how the heat distribution is created. So burner layout, we could have, as I said, floor firing, end wall firing, side wall firing. There is another firing which is terrace wall firing, was promoted by Foster Wheeler for steam methane reformers. So it's also very good way of firing. This is the end wall firing you can see over here. That is how all the old heaters used to be designed, end wall firing. Now we move to vertical firing or vertically up, and I think that is much, much better because of the buoyancy. The flue gases have a tendency to rise, so we can have straight flames. Then this is almost like a terrace wall firing you can see over here, or bi-level firing. There are several cracking furnaces where we have this type of firing. And then this is again a very old design where the burners are firing against a bridge wall in the center. And then we have the radiant tubes on the top. So that's kind of a sidewall firing, but that's typically the different. So another way we can classify the heaters is by draft. How, whether you have a natural draft heater, whether you have a forced draft heater, induced draft or balanced draft. So two drafts are very common, natural draft and balanced draft in the refining industry. That's typically the most common configurations of heaters. So again, we want to find out from you what type of draft system do you have on your fired heater, whether it is an induced draft, forced draft. Forced draft firing means you have an FD fan only. Induced draft firing means you have an ID fan only. Balanced draft firing means you have both the fans, both FD and ID, and most probably you will have an air preheater. And the natural draft firing means no fans. So that's typically how we can configure. So most of the furnaces or majority answered natural draft. Some people have balanced draft. Some people have forced draft, which is unusual, but hey, anything is possible. I really like forced draft furnaces because they have shorter flames. And then we have induced draft furnaces. So thank you for your feedback. Natural draft heaters, the stack creates a draft, no fans are required, and most common configuration in the refineries in the USA. They are the least expensive, most reliable, but also least efficient. So I think that is another area for when we are talking of greenhouse gas emissions that gives us a lot of potential to improve the efficiency of these natural draft furnaces, at least by about 10%, if not more, to reduce the emissions, greenhouse gas emissions. Balanced draft, as I said, is the one where we have the air preheater. We have a FD fan and the supplying the cold air to the air preheater, and it's preheated in the air preheater, and then hot air goes to the burners, and hot flue gas goes to the air preheater. Heat is recovered, and through an ID fan, the flue gases are sent back to stack. So this is a very common configuration in the refinery, especially in India and in Asia, where the fuel gas prices are very, very high. These furnaces are about 90-95% efficient. So very this thing. So I think this is what type of heater do you have? Do you have a horizontal tube cabin heater? You have a vertical cylindrical heater? You have a twin cell heater, or you have any other type of heater? Uh, so most of the people either have vertical cylindrical heater or horizontal tube cabin heaters, and some have twin cell heaters. So it's all split up. So now I want to talk about some of the common types of heaters. A vertical cylindrical heater with horizontal convection section, very, very popular. It is considered the workhorse in the industry, has a lot of advantages. Uh, Vertical cylindrical heaters became popular in 1950s. Low plot space, economical, we can have any number of passes. The convection section is very compact. Tubes can go up to, vertical tubes can go up to 60-65 feet. And heaters are built into this configuration. We can have heaters up to 150 or 200 by combining having two radiant cells, but generally 70 up to 75, this is a pretty good number for that. Horizontal tube cabin heaters, again, very, very popular. As I said, old heaters all used to be horizontal tubes. We can have it with a sloping arch, or we can have it with a flat arch. So those are the two variations. When we have a flat arch, we call it a box heater. When we have a sloping arch, we call it a cabin heater. So not much difference there. And then this is another configuration. We have a double fired vertical tube box heater, and the size is 20 to 200 million BTU. This is a configuration which is used in steam methane reformers, is used in cracking furnaces, also used in hydrotreater and hydrocracker heaters. So here the tubes are in the center and we are firing from both the sides. That's typically what we do. So that's typically the configuration. Again, very, very popular configuration. And then we have heaters for CCR, or what we call it a platformer. That's another configuration where we have large volume of gas to be heated. So we have large manifolds on the top or on the bottom. And then we have the U coils or inverted U, which we call it like an arbor. So and the burners can be on the walls. Burners can also be on the floor. And these can be double fired or these could be single fired. So these are the many configurations available for these heaters. That's again a common type of configuration. All right, Jordan. Okay, let's see. Okay, once again, you need to log in with a different PIN. This time, I need to do a little better job of integrating all the Kahoots. And since this is the first time I'm using a Kahoot, I'm still also in the learning mode. But the PIN is 6453159. So if you can log in again, that will be. So go to Kahoot and the PIN is 6453159. We will be talking about combustion. Combustion is one unit operation which happens only in heaters and boilers, does not happen in any other equipment in the refinery. So that is what differentiates fired heaters from heat exchangers or any other equipment, So very, very different type of unit operation, and combustion, in my opinion, is one of the most important operation which is taking place in fired heaters. It's always, combustion is always working actually. So we are also tight on time, so we'll start and try to complete this. So we'll talk about combustion and efficiency today in the last session of this webinar. So we have a combustion reaction happens in liquid phase, happens in solid phase, or happens in gas phase. Well, most of you got it right. Combustion reaction happens in gas phase. So even if you are burning liquid fuels or even if you are burning solid fuels, the combustion reaction happens in gas phase. Both the reactants needs to be in the gas phase for the combustion to occur. Thank you. So combustion requires following: oxygen, combustible fuel, a source of heat energy, or all of the above. Most of you got right. We need a combustible fuel, we need a source of oxygen, and we need a source of heat to start the combustion. So all of the above is the correct answer. Without this, it will not work.